So on this video, we're going to do some examples using the properties for logarithms, properties 3, 4, and 5. And for the last example, property 6, which is the change of base formula. So the way these are usually stated in this text, at least, is expand the expression as much as possible. Sometimes people will say, write using the simplest logarithms, means the same thing. I like expand the expression better. So you get log, first of all, I would write the cube, so I have log of the cube root of x squared y cubed over z. The first thing I would do is change the cube root to a 1/3 power because we have a rule for exponents. So I would apply the exponent rule, that 1/3 there just drops down in front here, and I get 1/3 log, it's log base 10, right? Log x squared y cubed over z. Then I can use the product and quotient rules, and I can do all three of these at the same time, for the x squared, the y cubed, and the z at the same time. Just put it in brackets because it's 1/3 times the whole thing. So 1/3 times bracket log x squared plus log y cubed minus log z. And then they want us to use the exponent rule to put this exponent 2 in front of this log, exponent 3 in front of this log. This is just practice using the properties in one direction. And then the next example, we'll use it in the opposite direction. Okay, so you get 1/3 times the quantity 2 log x plus 3 log y minus log z. That's expanded as much as possible. Notice the logarithms are really simple. It's log x, log y, log z. So sometimes you want that, and that's when you would do this. I distributed the 1/3. You don't have to. The only reason I really distributed the 1/3 is because it cancels for the middle term, you know, but that's not a great reason, but that's why I did it. Either one of these is correct. Okay, then the opposite would be compress the expression as much as possible. Some people would say write this as a single logarithm, something like that. And again, these are just exercises to practice using the properties. So I have ln natural log, right? ln of xy squared plus 3 ln of 5 minus 2 ln of z. The first term there's already compressed somewhat, but that's okay. We're just going to compress the rest of the way. Now, the thing is, our rule says you can have ln of something plus ln of something becomes ln of the product, right? Well, it doesn't say anything about ln of something plus 3 ln of something. So I have to get rid of this 3 here, or get it out of the way. Same thing with the 2. So I need to put that inside to get it out of the way so I can use my rules. Okay, that's very important. So I'm going to have ln of xy squared plus ln of 5 cubed minus ln of z squared. Now I can use the product and quotient rules here. So I get ln of 125x squared over z squared. 125 is just the 5 cubed here. 5 cubed is 125. So it's that times xy squared on top. Then the minus puts this z squared on the denominator. So we've written, so some texts will say write this as a single logarithm. You can see it's written as a single logarithm. And so often when we're solving equations, we want to do this. We want to write it as a single logarithm. So you can have like a single logarithm on one side of the equation, everything else on the other, and then you can compose both sides with the exponential function base e, like we saw in the previous examples. Okay, so my final example here is using property 6, which was the change of base formula. So it says estimate log base 5 of 3 to 3 decimal places. Your calculator doesn't usually have a log base 5. So you want to convert it to either natural log, ln, or a common log, log 10, base 10. So you just used ln. It doesn't matter which one you use, you get the same answer. You can try it if you want. So log of 3 base 5 is going to be ln of 3 over ln of 5. So the bottom is the ln of the base. So you change this log base 5 to the log you want, one you have on your calculator, right? And that's just the top one. You just change the base. And then on the bottom, you have to adjust it, the value, by taking natural log of the original base. And you see that works out. Now if you try log of 3 over log of 5, you'll see you get the exact same number. Try it. So I get 0.683, so to round to estimate it to 3 decimal places. So that's it for